Hello, and welcome to this Vicon training video. Today I will be focusing on the new series transform features. For the purposes of this demonstration, I am using Niagara AX Workbench version 3.7 on my laptop, and I'm running a station on my local machine. Series transform graphs allow Niagara users to manipulate series data for reporting purposes. Manipulation of the series data might include compositing data sets into a single data set, rolling up data into less granular samples, aggregating data sets together to create virtual data sets, or applying mathematical formulas to data sets. The series transform palette contains the station-side components which are used to define source data sets and to configure the specific manipulation. In the history space of this station, there are 5 numeric type histories, which are storing electrical consumption from 3 tenants in a building. 2 of the tenants have HVAC and lighting submeters installed, while the 3rd tenant only has a single submeter monitoring all of their electrical loads. The transform graph component is essentially a container object in which all the components used to define the data sources and apply the manipulation must reside. Dragging a transform graph component from the palette to the wire sheet adds the component to the station. Double-clicking the transform graph loads the wire sheet, which is the default view. To be considered valid, a transform graph must contain a single terminal node, and it must have at least one data source. The data source can be a history data source node, or another transform graph's output could be linked to this transform graph as a data input. The first step in developing the transform graph is to define the data sources. In the 3.7 build, the only allowable data sources are Niagara histories or other transform graphs. There may be additional types of allowable data sources in future builds. Dragging a history source component from the palette to the wire sheet adds the data source to the graph. Double-clicking the data source opens the configuration dialog. The source property is used to enter the history ORD to be used as the data source. The interval property is typically left at automatic, in which case the graph uses the interval defined in the history config parameters. The interval property can also be set manually using this drop-down selector. The interval property is configuring the time period to use when applying quantization to the datasets. Applying quantization to the datasets aligns all history records from various data sources within the specified interval, even though their actual timestamps may not match down to the millisecond. For example, one history might have a record at 3:15 a.m. and 1 second, while another history might have a record at 3:15 a.m. and 3 seconds. Applying quantization to the datasets, both records would be treated as if they had a 3:15 a.m. timestamp. The date range property configures the range of data from the source history which will be included in the dataset. You can specify an actual fixed time range, but it's more likely that you would select one of the floating time ranges, such as last week or last month. The source schema section of the dialog is used to define the schema of the source data. The schema defines the structure of the data and includes the column name and data type. Clicking the double chevron symbol opens the source schema editor dialog. The plus symbol is used to add a manual source schema definition. The field editors are used to enter the column name and the data type. For example, a Niagara history includes a column named timestamp, which is an ABS time type from the Baja module. A numeric history includes a column named value, which is a double type from the Baja module. The buttons with the minus symbols can be clicked to remove an item from the schema definition. The buttons with the asterisk character can be clicked to identify one of the items as the primary key. Typically, this will be the timestamp property, since the primary key will be used to apply quantization when combining multiple data sources into a single data set. By clicking the primary key icon for the timestamp item, a facet for the primary key is applied to the item. The double chevron symbols are used to open the facet editor dialog for a specific item. Notice the primary key field facet is already set. I could add other facets, perhaps for specifying a time zone, to format the timestamp value, or to apply units to the double values. In most cases, it isn't really necessary to manually define the source schema. By selecting an actual history in the source property, the history source node will automatically populate in the source schema. Notice the source schema was automatically populated, and the double chevron symbol is no longer available to edit the source schema. I will configure the time range to use a floating time range of last week. Each transform graph must end in a terminal node. Dragging a terminal node from the palette to the wire sheet adds the terminal node to the graph. The history source node needs to be linked to the terminal node using the standard wire sheet linking methods in Workbench. I need to link the transform output slot on the source node to the transform inputs on the terminal node. The dialog of the terminal node shows the schema, which it essentially inherits from the node which is linked to its transform input slot. The order of the schema fields is somewhat important because it determines the order of the columns when viewing the transform graphs as a data table. Using the arrow buttons next to each schema field, I can order the schemas to make the value column the second column in the table. This is really one of the simplest transform graphs that can be created. It includes one history source node and the required terminal node. In order to view the results of the transform graph, I can right-click the graph in the nav tree and select the Resolve Graph item. When I select the Resolve Graph item, it opens a dialog which allows me to adjust the parameters of the transform graph if desired. I could change the history specified by the source node. Or I could change the time range of the data to be displayed. In this case, I will just click the OK button to display the transform graph as a table. Notice the order of the columns matches the order of the schema fields from the terminal node, and the data is being displayed from the previous week because of the time range configuration. Let's take a look at a bit more complicated graph example. In this graph, there are 5 history data source nodes, one for each of the electrical consumption histories in the station. The only difference is the source property for each node specifies a different history, which can be seen by looking at the pinned data source slot on each node. To combine these 5 independent data sources together, I will use the composite node from the palette. The data source nodes are linked to the composite node using standard wire sheet links. Now that the data source nodes are linked to the composite node, I can go to the Composite Editor dialog to configure the schema fields of the new dataset. Notice the timestamp schema is predefined and cannot be removed. This is the primary key for all 5 of the history data sources and will be used to align records when combining the data sources into this single dataset. The button with the plus symbol is used to manually define the schema for the combined dataset. The first field editor is used to enter the schema's name. And the second field editor is used to select a column from one of the source schemas. The minus symbol can be used to remove a schema field. The button with the place symbol is used to automatically define the schema for the combined dataset using all the available columns from each of the data source schemas. Notice for each history, the schema fields include status and trend flags. In this case, I'm not really concerned with the status and trend flags columns, so I'll remove them from the composite schema. After removing the status and trend flag schemas, I'm left with the value schemas for each history. Notice that each schema ends with an underscore and the text string value. Since the schema name will be used as column headers in the table or the legend in a chart, I probably want to clean up these names. Since each transform graph must end in a terminal node, I need to add a terminal node to this graph. The composite node needs to be linked to the terminal node. The dialog of the terminal node will show the schema. This is the output schema of the transform graph. I need to reorder the schema fields so they are in order by the suite number. Now let's take a look at the results of this transform graph. Notice the collection table is displaying the columns in the order of the schema from the terminal node. It is important to note that this is a virtual data set, meaning there isn't a physical history in the station that stores all of these data values in a single history. This data set is resolved at runtime by resolving the transform graph. In summary, transform graphs allow Niagara users to manipulate series data for reporting purposes. A transform graph requires at least one data source and a terminal node, although it is more likely that transform graphs will be more complex with multiple data source nodes and other nodes for manipulating the data. The transform graph serves as a template to configure the data sources, time ranges, and the schema of the resolved data source. The template is applied at runtime when resolving the transform graph. Thank you for taking the time to watch this video, and be sure to watch the next video, which covers using aggregate, roll-up, and scale nodes in transform graphs. Also, stay tuned for additional Vicon training videos on other new features and changes in the Niagara AX framework.